So we're recording this meeting. Ah. Ah. Okay. It looks like everybody who's going to be here is here. Let's get started with chapter 8. The nice thing about chapter 8 is we're not learning any new formulas. These are just applications of the formulas we learned in chapter 7. So let's take a look at the first question. So they're talking about something here called a promissory note. And this is a legally transferable a legally transferable financial instrument. What it represents is someone or some company has borrowed money from some other person or company. And the piece of paper has to contain several important pieces of information. It has to contain the amount borrowed. Referred to as the face value. So they refer to it as the face value because that's the dollar figure you can see on the piece of paper. But this is the present value. And so in most of these questions, we usually need to find the future value. It also has to contain the interest rate. And this will be usually an annual rate, pretty well always. It has to contain the time period. And the time period can be in months or days, but we always have to calculate it in years. and what they call the date of issue. So that's basically how these promissory note problems work. They've got to give you those 4 pieces of information, and then we have to find out things like how much is going to be paid back on what particular date. So let's take a look at this question they've given us here. It says a 4-month promissory note. So that's the time period. Although they've given us months, we need to know exactly. I said always calculated here in years. That's a mistake. Always calculated in days, sorry. So although they've told us months, we need to know how many days that's going to be. The note was for 1,600, and that's the amount of money that was borrowed. And we're going to have to find out how much money is owed when this is due. The June 30th is when the money was borrowed. They haven't been nice enough to tell us the year, but it doesn't matter. And they've told us the interest rate. So we can sort of represent what this looks like on a number line or a timeline. Let's take a look at what we know here. So if we start here at today, someone borrowed $1,600, and this was June 30th, and this is going for 4 months. So 1, 2, 3, 4. So June, July, August, September, October, and whatever date we started on, that's the date we're going to land on every month. So this would be July 30th, August 30th, September 30th, October 30th. So we can work out exactly how many days that is using the days between dates on our calculator or going to Excel. Let's use the days between dates on our calculator. We'll go second date, and then we'll be looking at DT1, and we know it's the 6th month, so we have to put in 6. We know it's 30th, and we don't know the year, so we'll use 2021 because it doesn't matter which year we're going to use. And then we'll hit the down arrow or go enter and down. And then we're looking at DT2, and our second date is October, so that's the 10th month. So 10.3021, and we'll go enter and down. And now we're looking at DBD, which is days between dates. We have to go compute and it should do it for us. If you've done it and put it in the chat, that will be good. So we're looking at 122 days. So I don't have to do it because I trust that you have done this correctly. So 122 days. So we know this is 122 days. So it says, what is the due date for this note? And we've decided it's October 30th. What is the amount of interest payable on the due date? So if we're just calculating the interest, we'd use I equals PRT. And the principal was 1,600. The rate was 6.5%. And the time we now know is 120. Well, that didn't work. 122 over 365. So maybe somebody could calculate that, and I'll put that answer in there. When it says, what is the maturity value of the note? We now have two choices. We could take this number and add it to the 1,600, or we could calculate S equals 1 plus RT. So we're getting that this is 3476. And I hope that's a good answer. If we calculate S equals principal times rate plus rate times time, we'd get 1,600, 1 plus 6.5% times 122 over 365. That would be one way of doing it. Or the other way would be just to use this, and S equals principal plus interest. So 1,600 plus 34.76. So we're getting 1,634.76 here, and we get the same thing here. So in terms of the questions up here, what was the amount of interest payable at the due date? We decided that was 34.76, and the maturity value of the note 1,634.76. So that's sort of the basic problem that you'll be asked to do with promissory notes. Needless to say, the people that wrote your textbook will go out of their way to find ways of making it more confusing, but that's the basic situation. Any questions on that before we throw that away? Okay, I'll save that. And get rid of that. So a 120-day promissory note for 1,140 at 7.75% dated February 19th, 2021. So we need to do the same thing, basically. Here we are at today, but we know this is February. Feb 19, and they've given us a year this time. And the note was for 1140. So that's the face value. That's the amount of money that was borrowed. And they've told us directly that it was 120 days. So we could find the maturity value, but they've been annoying and asked us the due date of the note. So again, we're going to use our BA2 plus. We're going to go second date. And then we're looking at DT1. And we know DT1 is February. So the second month, the 19th day, and the year is 21. Then we're looking, we go enter and down. And then we're looking at DT2, but annoyingly enough, we don't know DT2. So we just hit the down arrow. Now we're looking at days between dates. And in this case, we know the days is 120. So we go enter, and now we'll hit the up arrow. And now when we hit that up arrow, we'll go back up to DT2. And now we can go compute. And we have a couple of different dates. Someone has said 6/19/2021, and someone has said October 30th, 2021. So let's try it and see what I get. Second date, 2.1921, enter down again. For DBD, I'm going to put in 120, enter up and compute, and I'm getting the 6th month, so that would be June. So I'm getting 6/19/21. So this would be June 6th of, oh no, so June 19th. June 19th of 2021. So make sure you can do that on your calculator. Now, let me just step aside here for a moment, and we'll take a look at how to do that on Excel if you're doing this on Excel. So I'll stop sharing this for a minute. Let's go find an Excel spreadsheet. So I'm hoping you can now see the Excel spreadsheet.
Yes, sir, we can.
Yes, it's visible.
Okay, so I've enlarged it a bit. And now the dates we were dealing with were February 19th. So when we put that into Excel, I'm just going to type in February 19, comma, space 2021. And Excel will put that in there. And then I want 120 days. So I'll just type that in. And then I'll go equals this plus this. And notice Excel has told me that it's June 19th, 2021. So it's probably easier to do it in Excel, although I'm kind of, I do it on the BA2 Plus just by habit. But if you have a computer available to you, it's easier to do the dates on Excel than it is to do it on the BA2 Plus. So,
Mr. Brown, the Excel
I'm
sheet is
unable-
empty.
oh, okay, my screen paused. I'll try that again. So can you now see the Excel screen again?
Yes, thank you.
Okay, let's do that again. I'm sorry, I didn't realize it had stopped showing you what I was doing. So just type in the name or the date, February 19, comma 2021, and then put in the number of days you want, 120, and then go equals this plus this. And it comes up with June 19th, 2021. So let's go back to the other screen. I just wanted to make sure you saw how to do that in Excel. So we've decided in a couple of ways that this is June 19th. So let's go back to our calculation or our questions. What is the due date of the note? And we've decided June 19th, 2021. So what is the amount of interest? Again, we could go I equals PRT, and the principal was 1140. The rate, they must have given us a rate, 7.75%, and 120 over 365. So I'm hoping a few people will calculate that and put it in the chat box. Okay, and to find the maturity value of the note, we could go S equals P 1 plus RT, which would be 1140 times 1 plus 7.75% times 120 over 365. So a few people have said this will be $29.05. And this will be 116905. So if anybody doesn't like these two answers, please let us know right away, because I'm going to trust you and go with them. So that was basically the same situation. The only thing different was finding the date where they didn't give us DT2. So let's save that. And see what else they can do to us here.
Mr. Brown,
Yes.
can you please repeat the previous question, means question number 1, because I entered the class little bit late.
Um, you want me to do question number 1 again?
Yeah, just repeat it. What are the calculation we did in the first part?
Okay. Let's take a look at that. So it was a 4-month promissory note. We created a timeline. And we're starting at June 30th. They didn't give us a year, but we're going 1, 2, 3, 4. And whenever you're moving forward, you're going on the same date. So June 30th, July 30th, August 30th, September 30th. This would be October 30th. And so we had to figure out how many days this was. And the amount of money that was borrowed was 1,600. And so in order to figure out the days, we went second date. June is for DT1. June is 6.30. And we chose this year, 2021. And then we go enter and down. Then we have DT2. And we've decided this is October, so this is the 10th month, 30th, 2021. Enter and down. And then we're looking at DBD, which is days between dates. We have to go compute, and we found out it was 122 days. So then the amount of interest, we calculated I equals PRT, which equaled 1,600 times 6.5% times 122 over 365 to get our answer. And to find the maturity value, we did S equals P 1 plus RT. And so it was 1,600 1 plus the rate of 6.5% times 122 over 365. And that gave us our answer. Is that good?
Yes, thank you.
Okay. And I'll send out the snapshot that has these answers on it.
Okay.
So let's look at question number 3. So now what they've done is they want us to find the face value, which on a promissory note is the present value. We know it's a 4-month note, and we know it was dated May 20th. So this is still the date it was written. And they've given us the maturity value. So what they're doing is they're basically making us do it backwards. But we can still start with our timeline. We still know we're starting on May 20th, and it's 2022. But we don't know how much the note is for. But we do know it's for 4 months. So 1, 2, 3, 4. So May, June, July, August, September. And we're going to move from the 20th to the 20th to the 20th. So this is the 20th, 2022. So the first thing we're going to have to do is figure out how many days this is. So I'm going to go second date. May is January, February, March, April, May. So DT1 is 5.2022. Enter down. And DT2 is September. So 5, 6, 7, 8, 9th month. Still the 20th day, 2022. Enter and down. And then DBD, go compute. And I'm hoping somebody is doing that and can tell us how many days this is. And we're getting a general consensus that it's 123 days. So we'll use that. Days equals 123. So now we're going to find the face value. So instead of using our formula that moves money forward, we're going to move money backwards. So we're looking for the principal equals S over 1 plus RT. And they've given us the future value of 1190.03. That's here. Divided by 1 plus the rate, 7.5%. And we can now do 123 over 365. And I'm hoping somebody is doing that calculation and will tell us the answer while I sit here and drink tea and pretend I'm earning a living. So we have one answer. We have another answer, and they agree with one another. So we're going to go with 1160.69. And so that's all there is to that question. One challenge to find the number of days, and then the second to do the actual calculation. So let's save that. And see what other ways they can try and ruin our day here. So it says, calculate the present value of a non-interest bearing 7-month promissory note for $1,800 dated August 7th, 2021 on December 20th, 2021, if money is then worth 9%. Now, I agree that the first time you read a question like this, it's quite confusing. So I'll try and explain what it is they're talking about here. To start with, we know this thing was dated August 7th. So let's start with that. August 7th, 2021. We also know it's a 7-month note. So 1, 2, 3, 4, 5, 6, 7. So August, September, October, November, December, January, February, March. So I'm thinking this thing matures on March the 7th, 2022. So we're going to need to know, well, we might not need to know how many days that is. So we'll leave that for a moment. So, and it was 1,800. But because it's a non-interest bearing note, this thing is still worth $1,800 here. In other words, someone loaned somebody else some money, but they didn't charge them any interest. That's what a non-interest bearing note would be. So we know this thing, when this thing matures on March the 7th, it's worth $1,800. It's this next piece of information that is very cryptic. What this tells us is that on December the 20th, so here at December 20th, 2021, this piece of paper was sold to somebody. And this second person only bought this piece of paper on condition that they would get 9% on their investment. So what we have to do is figure out, well, what were they willing to pay for this piece of paper on December 20th? They know that it matures to 1,800 on March the 7th, but they want to get 9% on their money. So we're going to need to know exactly how many days this is. So back to second date, DT1 equals December, so 12. And we've got to put 07. If you don't put the 0, your calculator will have a heart attack. And 21. Enter and down. And then DT2, March is the 3rd month. Still, oh, sorry. This is the 7th. I made a mistake. This isn't. This is 20. I'll see if I can erase that. This was December 20th. And then March the 7th, 2022, enter and down. And then you're looking at DBD, and you go compute. And people are telling us this is 77 days. That sounds good to me. 77 days. And so now we can calculate what someone would have paid for this piece of paper. We're still calculating the present value. Present value equals S over 1 plus RT. And we know the future value of this thing is 1,800. 1 plus 9% times 77 over 365. So it looks like it's time for me to have another sip of my tea. We're being told it's 1766.46. And we're being told by several people. So we're gonna go with that.
Excuse me, sir.
I hear someone talking, but I don't think they're talking to me.
Excuse me, sir.
Yes?
In the statement, how would you know that on December 2021 we have sold it?
Oh, the way the question is written, you wouldn't know it. But if you had been reading the textbook and read the examples, in the examples, you would see how they did it. But you're quite right. In the question, it's very cryptic. It says calculate the present value of a non-interest bearing 7-month promissory note dated August 7th, 2021 on December 20th. So what they're doing is they're telling you to calculate the present value on December 20th. And so that's what we did. We calculated the present value on December 20th. It just helps to understand that what must have happened is someone sold this note. So I do agree that the way they've written the question is very confusing unless you've done the examples that lead up to it to know what they're asking. Does that help any?
Sir, if we calculated days from August 7, 2021 to December 2021 for calculating the present value.
Do we need to know the number of days?
No, sir, for the present value, as the question demand, we have to calculate it on December 2020.
Yeah, we have to calculate from December 20th to March 7th, right? Because we need to know that this is 77 days. I'm not sure if I understand your question. I could mute other people. Let me find out.
So my question is that as the question demand that we have to calculate the present value on December 2021, then why would we calculate 77 days for December 2021 to March 2022?
We'd calculate the 77 days because that's how many days this this piece of paper will be accruing interest, right? Because the person who buys the bill on December 20th knows that this thing matures to $1,800. They also know that they want to get 9% return on their money. So they need to know, well, how much am I willing to pay for this piece of paper? So it collects interest for 77 days and becomes worth 1,800.
Okay, sir. Thank you.
So let's save that. And clear that. And let's go over to the next one they've given us here. So the same type of question. It says compute the proceeds of a 5-month, $7,000 promissory note dated September 6th, 2022 with interest at 5.5% if the note is paid on November 28th, 2022, when money is worth 6.5%. So we have to imagine the same sort of scenario. We have an original note that we'll have to figure out, and then it was sold. So let's draw a little picture here to try and depict what's happening to this piece of paper. It was dated September 6th, so we can start with that. September 6th, 2022. And it's 5 months. So 1, 2, 3, 4, 5. So September, October, November, December, January, February, and we're on the 6th. So this is February 6th, and we're now into 2023. And this thing was originally $7,000. And so the first thing we've got to do is figure out how many days that is. So let's do that. Second date, DT1, September is the 9th month, and it's 06/22. I'm already being told it's 153 days. So DT2, February 2.0623, days between dates, compute, and we're being told it's 153. Let's go with that. Days equals 153. So the only difference between this question and the one we just did is this one, there's a rate of interest. And so we've got to move this thing forward before we can do anything else. So 7,000, 1 plus 5.5% times the 153 over 365. So ignoring the last part of the question, what does this $7,000 become on the due date? We've got one answer, and we got two answers, and they agree with one another. We got three answers, so we'll go with those. 7161.38. So that's what this piece of paper is worth here. 7161.38. So now let's go over and do the second part of the question. If the note is paid or sold on November 28th, so we can find November 28th somewhere like here. November 28th, we're still in 2022. And so someone is buying this piece of paper on November 28th, and they're going to hold it until February 6th. And they are hoping to get 6.5% on their investment. So they have to figure out what they're willing to pay for this piece of paper here. And so the first thing they have to figure out is how many days this is. And so we're going to do the same thing. Second date. Date 1 is November, so 11.28.22. DT2 is still February 2.06.22, and days between dates. And we're being told by several people this is 70 days.
It's 23.
It's
2/6/23.
It's 23 days?
No, sir. Date 2 is 2/6/23.
2, 6. Oh, 23. Thank you. Yes. If I write it there like that, that'll look ridiculous. 23. So this is 70 days. And now we can work backwards because we know the maturity value. So what we're solving now is 7161.38 over 1 plus, and now the new interest rate they want is 6.5% times 70 over 365. And I'm getting an answer there, but that's a weird answer because we're moving money backwards. It's got to be less than 7161. So now I've got 7066 and 7073. Several people agree on the 7073. I'm going to go with the 7073.21, unless anybody can feel strongly enough to tell us that's not the right answer. So that's basically what they're going to make you do with promissory notes. They're going to make you take them forward and take them backwards. So let's save that. And the next thing they do in the first half of chapter 8 is they talk about something called T-bills. So let's take a look at how T-bills work. So T-bills or treasury bills, they're also legally transferable. And what I mean when I say they're legally transferable financial instruments is one person can sell this piece of paper to another person. That's what we saw happening with the promissory notes. One person can sell this piece of paper. And then the other person has the legal right to collect that money. But these things are issued by governments. um, either federal or provincial. So this is a situation where the government is borrowing money from people. And T-bills are always less than 1 year. They come in denominations like 30 days or time period 60 days, 91 days, 182 days. Once in a while, they do 183 days and 364 days. Annoyingly enough, the 364-day T-bill is called a 1-year T-bill, but it's still 364 days. It's just confusing that they call it a 1-year T-bill because it is only 1 day short of a year, but it's called a 1-year T-bill. But when you calculate it, it has to be 364 days. So the next thing you have to understand about a T-bill is what they call the face value is the future value. So that takes a little bit getting used to, because when they talk about the face value of a promissory note, they're talking about the present value. But when they talk about the face value of a T-bill, they're talking about the future value. So that's the actual dollar value that's printed on the bill. That's why it's called the face value. And what this means is T-bills are always sold at a discount. In other words, the basic T-bill problem is we need to find the present value. So let's take a look at this T-bill that they've given us. Well, it'd be nice if they'd given it to us. It's worth $25,000, but they didn't give it to us. They've just told us we have to work with it. So it says, what is the price of a 91-day $25,000 Government of Canada Treasury bill that yields 1.28% per annum? So for some reason, they don't talk about the rate of interest on a T-bill. The terminology they use is they refer to the yield on the bill. But this is still our interest rate. So let's draw a picture here to see what it is we're going to do with this thing. And so we know it's a 91-day T-bill. So we can start with our 91 days. And it's $25,000, but that's the maturity value of the T-bill. And we also know that it's 1.28% And they're expecting us to figure out what the price of this thing was. So we're always discounting this or finding the present value. So we're going to calculate 25,000 over 1 plus 1.28% times 91 over 365. So I'll give you a few minutes to calculate that while I have a sip of my tea here. I'll put the word sold in here, it'll help. Always sold at a discount. So we're getting a few answers and they all seem to agree with one another. So I'll be agreeable and go along with that. 24,920.47. So that's the basic T-bill situation. Needless to say, they've gone out of their way to find ways of making it much more confusing, but that's the basic situation. Always remember what they refer to when they refer to the face value of a T-bill, they're referring to the future value. And when they refer to the yield, that's the rate of interest. So let's put that away and see what else they can do to make it more confusing.
Excuse me, sir.
Yes,
Sir, if in the question they give us 364 days and not mentioning 1 year, we'll take it out as a 1 year.
if they give you a question that says a 1 year T-bill, then you know you're calculating it as 364 days. But when you're calculating in 91 over 365, it's still always over 365.
364 over 365.
Yes, if it's a 1 year bill, it's 364 over 365.
Okay, sir.
So what have they told us here? An investment dealer paid $24,656.25 to acquire a $25,000 182 Government of Canada Treasury bill at the weekly auction. What was the annual rate of return on this bill? So let's see what we know here. We know this thing is a 182-day bill. So we know we're dealing with 182 days. We also know it's a $25,000 T-bill, meaning it matures to 25,000, but they've told us what they paid for it. 24,756.25. And so they're asking us to find the annual rate of return or the interest rate. And we have a formula. We started with I equals PRT, but they're asking us to find the rate. So we had to go R equals the interest amount over the principal times the time. But they haven't actually given us the interest amount. So what we're gonna have to do is find the difference between these two. 25,000 minus 24756.25 over, and the principal is this 24,000. That's how much they invested. 24,756.25 times the time of 182 over 365. And once we're finished all this nonsense, we're going to have to multiply it by 100 to turn it into a percentage. And so the first thing I would do is figure out what this number is at the top. 25,000 minus 24756.25. So this is $243.75. So I would start down at the bottom here with 182 divided by 365 times 24756.25. And then I'd flip it into the numerator by going 1 over x and times 243.75 equals, and then I go times 100. And I am indeed getting 1.97%. They haven't told us how many decimals this answer should be, but I've got my calculator set to 2, but I can store it in register 7 and go second, format, 9, enter, clear, and recall, and see that I'm really looking at 1.974609.586. So I'd have to find out how many decimals they wanted and give them whatever they were asking for. So any questions on how that calculation worked? Before they do anything else nasty to us?
No, sir.
Okay, let's clear that. Make sure it's saved. For some reason, that was weird. What else can they do to us? So an investor purchased a 182 $100,000 T-bill on its issue date. It yielded 3.85%. The investor held the T-bill for 67 days and then sold it for $98,853.84. So part A says, what was the original price of the T-bill? And then in part B, when the T-bill was sold, what was its yield to maturity rate? So let's draw a picture. Don't know why we want this saying 11. That's ridiculous. let's draw a picture here to show us what it is we're trying to do. We know this is 182 days. And we know it's at 3.85%. And it's a $100,000 T-bill, so it matures to 100,000. And the first thing we need to find out is what did the investor pay for this bill? So we have to take the 100,000 and we have to discount it or find the present value. So 1 plus the rate of 3.85% times 182 over 365. So I'm hoping that if I look at the chat box for long enough, someone will come up with an answer there. I see one answer. I see another answer. They both agree. A third one, I think we're going to go with that. 98116. Oh, now I see two answers. Why? I see 4.3 and 6.4. We're going to go for the 4.3. Let's go for the 4.3 then. And if that turns out not to be what you're getting, let me know. So that's what this thing was worth here. 98116.43. So that's really the first part of the question. What was the original price of the T-bill? 98116.43. And now we have another situation. It was sold. So the investor held it for 67 days. So 67 days. And they sold it for 9,853.84. And they're going to buy this piece of paper here. They're going to hold it for this many days. And it's going to mature to be 100,000. And so we need to first figure out how many days are left, which is fairly easy. 182 minus 67. That 182 minus 67 is 115 days. And so now we have our problem again of finding the rate. We know what it matures to. We know what they paid for it. We know how many days they're holding it, but we have to find the rate again. So the rate equals the interest amount over the principal times the time. The interest amount we have to calculate separately. 100,000 minus 988 53.84. And the amount they paid for it was the 98853.84. And the time is 115 over 365. So again, the first thing I'm going to do is figure out this top number, 100,000 minus 98853.84. So this is 1146.16. And then we're going to go times 100. We still don't know how many decimal places we're working to. So let's see, 115 divided by 365 times 98853.84, 1 over x, and then times 1146.16. For some reason that didn't work on my calculator. 115 divided by 365 times 98853.84 equals 1 over x times 1146.16, and then times 100. And I agree with the answers I'm seeing in the chat box there. I'm getting 3.679990756%. And so we'd have to know how many decimal places. If they're asking for 2, it'd be 3.68%. So those are the kinds of annoying things they can get you to do with T-bills. But you just have to remember that the future value of the number they give you is usually the future value. It's usually the number that is a nice round number. It'll always be the future value for the T-bill questions. So let us save that. And now we'll move on and take a look at what they've done to us for compound interest here. So I will stop sharing this whiteboard and we'll get rid of this. And we'll find those Excel sheets. Oops. So I'm hoping that you can see my Excel sheet. Let's enlarge this a little. So let's make sure we're all on the same page here, literally. You can all see the Excel sheet. Anybody that cannot see the Excel sheet? Okay, I'll take that as a good sign. So let's read the question and then figure out what they're really asking us here. Hine Engineering expects to expand its plant facilities in 6 years at an estimated cost of $75,000. To provide for the expansion, a sinking fund has been established into which equal payments are made at the end of every 3 months, and interest is 4% compounded quarterly. So the important word here, or words, are the words sinking fund. A sinking fund is where a company has a bank account and they're putting money in that account to save up money to either pay something off or to be able to have a chunk of money to do something with. So what they're doing here is they know that in 6 years, they're going to have to pay $75,000. And so they're saving up to have this $75,000 when they need it. So when you see a question referring to a sinking fund, what they're doing is they're saving money. As opposed to the questions we did in chapter 14, where we're talking about amortization. Amortization is where you've borrowed money and you're paying it off. And with amortization, you're paying interest on the money you've borrowed. A sinking fund is the opposite. You're saving money and you're being paid interest on the money you're saving, right? So that's what we're dealing with here. We're dealing with what they call a sinking fund, but they basically mean a saving fund. So we can see this as an ordinary annuity because the payments are at the end of every 3 months. And we can see it's a simple annuity because we're compounding quarterly and payments are quarterly. So we'll keep those concepts in mind when we start to figure out which formulas we need. So the first thing they need to know is what is the size of the quarterly payments? They know they're trying to end up with 27,000, but they got to figure out how much money they're going to put in every 3 months. So we have a formula for this, formula 11.1a. We just solve for the payment. And if we plug the numbers in correctly into your calculator, we should get this 2,780.51. Or we could do it on Excel. Oh no, first off, we do it on the BA2 Plus. It's quarterly, so PY equals 4. There's 24 periods. How did we get 24 periods? It's 6 years, 4 times a year. So we had to come up with the 24. The interest was 4%. They must have told us that. Yes. We start with no money. We don't know the payment, but we do know we want to end up with 75,000, and we compute the payment and we get exactly the same answer that we got when we calculated it by hand. And if that wasn't fun enough, we can do it on Excel. The rate, notice we had to calculate the rate. We had to take, what was it? Equals 4% divided by quarterly, so it's 4. And we had to come up with 0.01 here. The number of periods is still 24. Present value is still 0. Future value is 7,500. And the type is 0. The reason the type is 0 is because this is a ordinary annuity, not annuity due. If it was annuity due, we'd have had to put a 1 in here. And so we've come up with exactly the same answer, even though we're throwing away the negative sign. Here, we would have probably got a negative sign too, but I threw it away. So then they want to know how much of the maturity value will be made out of payments. So the first thing we need to do is find the total amount paid, the sum of the payments. So 24 times the payment equals this. So although we're trying to gather up 75,000, we actually only put 66,000 and something in there. And how much interest will the fund contain? Take the 75,000 minus the amount we put in, and we find that over the term, the 6-year term, we earned 8,000 and something interest. Now, we could also use the BA2 plus, and we could come up with an answer here. Once we've completed the payment calculation, that was this one here, we could go second amort, and P1 equals 1, P2 equals 24, so we're going all 24 periods. We see the balance is 75,000. The amount the principal is 75,000, and we come up with an interest of $8,264.74, which is close. We're only 2 cents difference than our calculation. So either way you do it, Moodle would accept either of these answers as being correct. Or we could create what I call a sinking fund schedule, which is really an amortization schedule. The nice thing about doing it this way is it at least lets you see the whole sort of process for 24 payments. And as I've sent you this file, you can take a look at the calculations being involved here. And I always add the rate on the side here, it's easier. But we can see that at the bottom, if we sum up this interest column, we can see how much interest we've paid. And this gives us the same answer as the BA2 plus. So any questions you can think of asking about how that worked? We'll do a few of them, but that's basically how a sinking fund works. Let's take a look at the next one. Enlarge this. Okay, for some reason I'm losing a word here. Let's see if we can find it. Months, okay, good. So to redeem a $100,000 promissory note due in 10 years. So they know they're going to have to pay $100,000 in 10 years. They've set up a sinking fund, and The sinking fund, they're earning 5.5% interest compounded semi-annually. And they're going to make deposits at the beginning of every 6 months. So the first thing we know is that this is an annuity due because they're making payments at the beginning of every 6 months. And we also know it's a simple annuity because it's compounding semi-annually and the payments are semi-annual. So the first thing we're being asked to do is find the size of the payment that they have to put in. And in this case, we're solving for an annuity due. So there's this extra 1 + I term in here. But if we plug this into our calculator, we should get this answer. If we don't want to plug it into the formula, we can plug it into our BA2+. The first thing we need to do, because it's annuity due, is we have to go second BGN, second set, and you'll see the little BGN up on the corner. It's a simple annuity, so we only have to set periods per year. It's N is equal to 20 because it's 10 years and 2 times a year. So 20 makes sense. The interest is 5.5. Again, there's no present value. We don't know the payment. We do know the future value. And when we compute the payment, we come up with exactly the same answer. And I've probably thrown the negative away because we don't need it. And we can do the same calculation on Excel. We had to calculate the rate. What did we have to do? We had to go equals, and what was it? 5.5% divided by 2 because it's semi-annual. And so we had to calculate the rate for Excel, but the number of periods is still 20. Present value is still 0. The future value is still 100,000, but the type has to be 1 because this is annuity due, not ordinary annuity. So if we plug those in correctly into Excel, we should get this value here, and then we're going to throw the negative away anyway. And that's the same number we got by our other 2 methods of calculating. Once we know that payment, then we can look at the questions they're asking us. How much of the maturity value of the fund will be deposits? So we take the payment we just found times 20, and we find that they're actually depositing 74,300. And so now we need to know, well, how much of the money they end up with in the fund is interest. We know they end up with 100,000. We take away the payments and we find that they're getting $25,699.80 in interest. Now, weirdly enough, I couldn't get the calculator to work with BGN and a sinking fund. I don't know why that didn't work. I couldn't find anybody on the internet that could tell me how to do that. So I've never figured out how to do this with the amort function on the BA2+. So I did find that if I changed the number of payments from 20 to 21, I got the correct answer for the interest, but the balance and the principal paid didn't make any sense. So even though there was 20 payments, I found that I could put in 21 and I got a number for the interest that was in fact almost correct, only 1 penny off. But that's highly unsatisfactory, so I wouldn't recommend doing it. We could create an amortization schedule. And I say here,
Excuse me,
take careful note of the differences between an annuity due sinking fund and an ordinary annuity sinking fund.
Excuse me, sir.
Yes,
Sir, can you show the BA2 plus solution on the
Yeah.
Excel sheet?
can I show the BA2 plus on a
No, sir.
spreadsheet?
Yes, yes.
I'm, you mean
Yes,
on
sir.
the calculator I have, or
No,
on
sir,
the,
no, not calculator, this one.
on the sinking fund, on an actual schedule?
Sir, actually, I got the different answer on BA2.
Yes,
Sir, I got the balance in 103,715.01.
715.01.
Yes.
Yeah. I'm not sure. Yeah, it doesn't really, that number doesn't really make any sense anyway. Whether it's this number or the number you got, it doesn't make any sense in relation to the question. But strangely enough, when we look at 21 periods, the interest comes out correct. But I would recommend not trying to do it on the BA2 plus, because it doesn't really seem to work very well. You want me to do it on the calculator on the screen?
No, sir, it's okay.
Okay. Yeah, I would do it. I would learn how to create this schedule here, or just do the calculations by hand. They're not difficult calculations. Just do this times 20 and then 100,000 minus that, and you'll find out the amount of interest. This is the easiest way to do it, but you can also look at the entire schedule. Let's take a look at how that worked. Because it's annuity due, and you're putting the payment in at the beginning of the period, you're going to get interest on the first period here. Let's look back at the previous one we did. Notice here, because this one wasn't annuity due, and we didn't put the payment in till the end of the period, we didn't get any interest here. But on this one, because we put the payment in at the beginning of the period, we do get interest here. So it makes a slight difference to your calculation that with annuity due, you're getting this interest in this first period. And then we could calculate the table. And when we add this up, we get the same answer we got by the previous calculation. So take a look at how these spreadsheets work, because it does give you at least a complete visual image of how the whole calculation worked. But the most direct way to do it is just, once you know the payment, just calculate them by hand, because it's just two calculations to find out, first off, how much will be deposits and how much will be interest. They're fairly straightforward calculations. So let's look at what else they can do to us to make this more confusing. So we have something called Winooski Lamp Company. They borrowed $95,000 for capital expansion. The company must pay interest on the loan at the end of every 6 months. So they've borrowed the money, they're paying interest on the amount of money they borrowed. And at the same time, they're putting payments into a sinking fund to pay back the 95,000. So the 95,000 is like a bond, and they're paying coupons or interest on the bond, but they also know that they have to pay the 95,000 back in 20 years. So they've got to save up 95,000. So they're basically doing two things here. They're paying interest on the bond, and they're putting money into a sinking fund to pay the bond back. And so they're in a complicated situation. There's one rate of interest that they're paying on the bond. So this is the amount of money they're paying, and they're saving money in the sinking fund, but they're only getting paid 7% in the sinking fund. So we now have to keep track of both of these ridiculous rates of interest. And I don't know whether they were trying to make it easier or not, but they want us to round all answers to the nearest dollar. So we're no longer worried about pennies in the end. So I've tried to explain the two situations here. Notice that there are two situations and interest rates to be considered here. The money borrowed, 95,000, is borrowed at 9%, but the sinking fund that is being used to save up enough money to pay off the loan is only earning 7%. So it's an ordinary annuity because they're making payments at the end of every 6 months. And it's a simple annuity. Both the loan and the fund are compounded semi-annually, and payments are semi-annual. So the first thing they do is they want us to determine the size of the periodic interest expense of the debt. This is the coupon payment, right? The person who this was being paid to, they would have a bond, a $95,000 bond, and they'd be looking at these as the coupon payments. So we'll calculate this, the 95,000 times 9%, but we've divided it by 2 because it's half a year, because it's semi-annual, and the coupon is 4,275. So we know part A, and then determine the size of the periodic payment into the sinking fund. And this is dealing with the fact that the sinking fund is earning 7%. And we have a formula that we've already used, 11.1a. We can find the payment. The payment came out to $1,123.59, but they said round all numbers to the nearest dollar. So we'd have to report the payment as 1,124. So whenever we deal with this payment, it's going to be $1,124, not the actual value that we calculated. We could do the same calculation on the BA2 plus. We have to make sure BGN is not up as we used it previously, but we don't want it there now. It's semi-annual. We're going for 40 periods. Where did the 40 come from? 20 years, twice a year, 40 makes sense. 7%, 0 present value, we don't know the payment, $95,000 for the future value. We come up with the payment and we round it to the closest dollar, 1,124. And we can do this calculation on Excel. In this case, we had to find the rate. What was it? Equals 7% divided by 2. So we had to do this calculation separately and put it in here. It's 0, says it's an ordinary annuity. And we come up with this value. We throw the negative away because we don't need it. And we also round it to the nearest dollar. And either way we calculate it, it comes up to 1124. Now they've asked us, what is the periodic cost of the debt? And what they mean is, how much is the debt costing us every 6 months? But we have two things to consider here. Winooski is paying the coupon of $4,275, and they're also paying $1,124 into the sinking fund. So the periodic cost of the debt is the sum of both of these. They're paying $5,399, again, rounded to the nearest dollar. That's what they're paying on a regular basis to service this debt. And then they ask us, what is the book value of the debt after 15 years? So where are they after 15 years? So this is 30 semi-annuals. And so what we need to do is find the future value of the payments and then subtract the value of the payments from the full value of the loan. So again, we're using our payment calculation, but now we know the payment and we're trying to find the future value of the payments. And the payment we're using is the 1124, not the actual value. We're using the rounded value. And so we find that the future value of these payments would come up to 58,000. And we subtract this from the full value of the loan. So we find that 95,000 minus this equals 36,976. And again, we're rounding to the nearest dollar. And strangely enough, we could do this calculation on the BA2 plus. And we don't have to do two calculations. Once we've done the payment calculation with the calculator set to 2 decimals, we found the payment of this, but we've got to round this to 1124 and put this into payment. So you have to do the calculation, go compute payment, and then change it to the nearest dollar and put it back in. And then we can use the amort function with the rounded payment. Go second amort, P1 equals 1, so we're starting at period 1. P2 equals 30, so we're going to period 30. And then we find the balance of 58,023.89. And then we have to use this balance to calculate it by hand. We'd still need to subtract this from 95,000. So you could use this formula, or you could use the amort function. You'll get the same balance after 30 periods. And it's also useful to make sure you know how to calculate or create the amortization schedule, which is now called a sinking fund schedule. Because if we go to the 30th payment, we can see the exact number we're looking for in the balance column. We can also see the 36,976 in the book value column. So here, where we had to calculate the 36,976, when you're creating a sinking fund, you have the balance, which is showing you how the money is adding up. And you have the book value, which is basically working down from 95,000. So in the schedule, we get both the future value of the payments and we get what the book value would be at that point. The book value meaning how much is left to earn on the sinking fund. So what they did in this question to make it more complicated was giving us the situation where we had to worry about the money they'd borrowed and that interest rate and the interest rate they were getting on the money they were saving. Let's see what they can do in the next question to ruin our day. So the town of Keewatin issued debentures worth 120,000, maturing in 10 years, to finance construction of water and sewer facilities. So debentures are like bonds. They've borrowed the money and they're going to have to be paying it back. To redeem the debentures, the town council decided to make equal deposits into a sinking fund at the beginning of every 3 months. Interest earned by the sinking fund is 6% compounded quarterly. So we're not worried about the rate of interest they're paying on the debentures here. We're only worried about the fact that the sinking fund is earning 6%. This is an annuity due because they're making payments at the beginning of every 3 months. And I've said here it's a simple annuity. And it's because the payments are every 3 months and it's compounded quarterly. So we need to calculate the payment. Because it's annuity due, we have this extra 1 plus I term here, and we can come up with the payment. We can do this on the BA2 plus. We again have to make sure BGN is up. And the payment periods are quarterly. There are 40 payments. Is that right? 40, 10 years, 4 times a year, 40 makes sense. The interest rate is 6%. We don't know the present value. We don't know the payment, or we know the present value is 0. We know the future value is 120,000. We compute the payment. We come up with the same answer. in this case, we're not rounding it to the closest dollar. We can do the same calculation on Excel. How did we come up with that number? Let's see, the interest rate was what? 6% divided by 4. So that we had to do that calculation separately. We know it's annuity due. So this has to be a 1. And if we do those correctly, we'll come up with the same answer. And so the next thing they ask us, once we know the payment, is what is the balance in the fund after 6 years? So we start by finding the future value of the payments after 6 years or 24 periods. And we come up with a future value of 63,000. And so that is the balance in the fund, is the 63,000. I tried to use the amort function on the BA2 plus, but because it's annuity due with BGN up, I couldn't find any numbers that would make any sense. So if you ever figure out how to use the BA2 plus function with an annuity due, please let me know. But I couldn't figure it out. Now they want to know how much interest is earned by the fund in the 28th payment interval. Like I said, what a stupid question, but they asked it anyway. And what we have to do here is find the future value of the payments after 27 payments. And then because this is annuity due, add 1 payment because they're going to get paid interest on that 1 payment. And then multiply this amount by I to see how much interest was earned in the 28th period or payment period. So if we calculate this by hand, you have n equals 27. We find the first step is to find the future value of the payments. The second step is to add 1 payment. And then the third step is to calculate the interest accrued on that. And so we come up with 1,126.80. So it's a 3-step process to find that. And then they've asked us, by how much will the fund increase in the 33rd payment interval? And this is even worse than the last one. This becomes a 4-step process. We're worried about the 33rd payment interval, but we have to find the future value after 32 payments. Because it's annuity due, we add 1 payment. Then we multiply this amount by I to see how much interest was earned in the 30, I don't know what TH is, that's ridiculous. 33rd period. And so these 3 steps were the 3 steps we had to do in part C. But now we have to add the interest that is accrued to the payment to see how much has been added to the fund. So we have to do these 4 steps, and here they are. We calculate the future value with n equals 32. So we come up with a future value. The next step is to add 1 payment to that. So this is the amount that will be accruing interest. The third step is to actually calculate the interest. So this is the amount of interest that will be added. And then we have to add the interest to the payment to see how much we're adding to the fund. So we had to do all those steps. Now, we can create a sinking fund schedule. Our columns are the payment numbers, the payment amount, the interest. And remember, we get interest on that first payment because it's annuity due. This is the increase in the fund where we've added these two. This is the balance of the fund where we're adding the previous balance to the increase. And then this is the book value where we're taking this increase away from the book value. So we're working down this column and up this column. And so the first thing we were looking at was the 28th payment. So we can go all the way down to the 28th payment. I don't know why I've highlighted 24. Let's get rid of that. The 2027, which we calculated, and we can see the interest in the 28th period in the schedule. And then they do the same for the 33rd. We can see the balance after 32, the interest, and the amount that's being added in this increase column. So if we create the schedule, we can see the numbers we need that we've generated by the calculations. So we've only got one other question to look at. Let's see if they've done anything terrible to us here. So the township of Langley borrowed $300,000 for road improvements. The debt agreement requires that the township pay the interest on the loan at the end of each year and make equal deposits at the time of the interest payments into a sinking fund until the loan is retired in 20 years. Interest on the loan is 8.25%. So that's the rate they're paying on the money they borrowed. And interest earned by the sinking fund is 5.5% compounded annually. So again, we have to keep track of both of these rates. They're paying a certain rate on the money they borrowed and a certain rate on the money they're saving to pay off the 300,000. And we're going to round all answers to the nearest dollar. So it's an ordinary annuity and it's a simple annuity. So again, they say, what is the annual interest expense? From the point of view of the person who is loaning them the money, this is the coupon payment. So we take the 300,000 multiplied by the rate, and we find that the coupon once a year, an annual coupon, is paying $24,750. We have to find the deposit into the sinking fund. This interest rate is at the 5.5%. It's an ordinary annuity. So this is our formula. And we're going to round our answer to the nearest dollar. So they're going to make payments of $8,604. We could calculate this on the BA2 Plus. And we could calculate the same result using Excel. Then they ask, what is the total annual cost of the debt? Meaning, what is the periodic cost? What's it costing them every year? So we know they're paying 24,750 in interest on the loan. And we also know they're paying 8,604 every year into the fund where they're saving money. So periodically, every year, this is costing them $33,354. So how much is the increase in the sinking fund in the 10th year? So we have to do the same nonsense we had to do in the previous question, but because this is a ordinary annuity, not annuity due, we don't have to add that one payment. So we find the future value of the payment in the 9th year, multiply this value by the interest rate, and add this value to the payment. So, and this rate is the 5.5%. So this is where we actually do this. We find the future value with n equals 9, multiply this by the interest rate, and we get this amount of money, and we add this amount to the payment to see how much the fund is increasing every year. And we're rounding this answer to the nearest dollar because we were told to. Now we could do part of this calculation on the BA2 plus. We're only worried about the 10th year. We can see the balance, but PRN is the amount we're adding to the fund. So we actually get this answer directly. We're going to round it to the nearest dollar. But amazingly enough, with the amort function, we can see this amount that's being added to the fund every year in the PRN column. So then they ask us, what is the book value of the debt after 15 years? We're going to use the rounded value for the payment here. And so we find the future value. So the future value is this, the 192,000, but we have to subtract the value of the payments from the full value of the loan to find out what they call the book value of the debt, meaning how much money is still left to be earned. And amazingly enough, we could find this 192,000 using the BA2 plus amort function, but we'd still need to subtract this from 300,000 to get the book value. If we create the sinking fund schedule, which is an amortization schedule, one of the columns is in fact the book value. So this number here, that was the book value, the 107,196. We should see this in here for 15 payments, and there it is, 107,195.87. But of course, they've said round all answers to the nearest dollar, so we would have to round this to the value of 107,196. But when you create this schedule, it automatically will keep track of the book value for you if you've managed to program it correctly. So that's all the pain and agony I can inflict on you for today. I'm recording this, so I will send you the recording. The other day, yesterday, I recorded the session we had in the office hours, but the recording took so long to sort of compile on YouTube that it wasn't finished. It wasn't ready when I went to bed at about midnight last night. So I'll see if it's ready today, and I'll send you the link. And then when this one compiles, I'll send you the link for this one as well. So
Mr.
Yes.
Brown, just a question. On the last example, when we calculate the future value of letter D, there's no way to get it through BA2 plus, just by the shorthand method, because on letter E, we were able to obtain the future value using the calculator.
let's see. Here, we used I rounded the payment to 604. I put this into payment. I used the amort function, and we were only worried about the 10th period because they said the increase in the fund in the 10th year. And the increase in the fund, what we figured out, the increase in the fund was 13931. And that's what this would be. This would be the increase in the fund if we rounded it. Let's go equals round this, comma 0. This would be our 13931. Is that what you're asking?
Yes, but to get number 1 future value, we can only do it by shorthand, right? By hand.
To get number 1.
The 96848.86.
Oh, future value. Oh, no, we should easily be able to do that on the BA2 plus.
Okay, we can do that, but
That's-
it's just not shown here below.
Yeah,
Okay.
yeah.
Because on for letter E, we were able to calculate the future value on the BA2 plus part, which is
Here.
192,804.
Yes, we should be able to do this on the BA2 plus. Let me see what we'd be putting in there. Because we'd be putting in second PY1, it's annual, right? And then we would have, what would we be putting into N? 15 into N, right? And the interest rate would be 5.5 into IY. I'm just writing this down, and then we'll do it on the BA2 plus on the screen, see if it works. 5.5, and then the present value. We don't know the present value, so the present value would have to start at 0, and the payment would be 8604, but it would have to be negative into payment. And then we don't know the future value, but we'd be computing the future value. So let me stop sharing this and find my calculator again. So can you now see the calculator?
Yes.
Okay, let's clear this. And so this is not annuity due, right? Not annuity due. So we don't want BGN up there. And so we'd go second PY, it's annual, 1, enter clear. And so 15 into N. Now it's 5.5 into IY. 0 into present value. 8604, but negative into payment. And then we're going to compute the future value. So compute future value, and we get 192,804.14, which is, yeah, exactly the answer. So yeah, for some reason, I just neglected to put that calculation here, but we could do it.
Okay, thank you. I just thought that the only way is by hand.
Yeah.
All right, thank
And
you.
so the other one, we could do that one exactly the same way. Do you need to see it, or you'll just believe me?
I'm okay with it. For letter D, we could also do the same way through the calculator, right? For letter
Yeah,
D, future
that's right.
value.
Yes,
Okay.
exactly the same. You could calculate it. For some
Okay,
reason, I
thank
just
you.
neglected to put it here.
Okay.
I don't really know why. I didn't think of putting it there, but it could be done. Any other questions that people can think of asking? All the kind of thing, I know that when you're given this much information in 2 or 3 hours, it doesn't really make sense until you try to do the calculations yourself. So please add the BA2 plus calculations on the Excel sheets and then resend. Yes, I will do that. That's a good idea. Those BA2 plus calculations that were not present, I'll add them and I'll resend that. Good suggestion. Any other suggestions that people have? Okay. Having said that, and not seeing any other questions, I will say goodbye for today. And I'm sure if you have questions, I will hear from you during the week.
Uh,
Take care.
Mr.
Yes,
Brown,
yes.
can you do the first question of bond evaluation right now? Because I'm trying to solve the assignment of the bond evaluation, but I don't know how to start it because I'm confused between the values. Can you do the first part of it?
Is that the first one of the homework?
Yes.
Okay, let's take a look here. And so this is bond valuation,
Yeah.
and this is Manmeet.
Yes, sir.
Okay, we'll find yours. Manmeet Sharma. So let's bring the first part over here. Share. So the first thing you want to do is make sure you have a copy of the chapter 15 formula sheets. Because I'm hoping the formula sheet makes sense. And if you find the formula sheet doesn't make sense, then you need to work with me to sort of rewrite or revise the formula sheet so it does actually make sense. So the very first thing on the formula sheet that you see is premium or discount. And it says, when the market rate I is lower than the bond rate, the value of the bond goes up and the bond will sell at a premium. Or it says, when the market rate I is higher than the bond rate, the value of the bond goes down and the bond will sell at a discount. So let me explain how that works. When they borrowed this money, they could borrow money at 6.5%, right? So that was the interest rate that was available in the market when this bond was written. But since then, the interest rate has gone down. Right? And if the interest rate has gone down and you were given the choice of investing at 5.2% or buying an investment that was worth 6.5%, you would say to yourself, well, 6.5% is a better rate of interest than 5.2%. And so I'd prefer to buy the interest or to buy the investment that is paying 6.5%. So because it's preferable to buy an investment paying a higher rate of interest, in this case, this bond will sell at a premium because the bond is at a better rate of interest than you can get anywhere else in the market today. And so that's where it says, if the bond rate I, if the market rate I, which is the 5.2%, is lower than the bond rate B, which is the 6.5, the value of the bond goes up and the bond will sell at a premium. So before we go any further, does that make sense? That you're comparing the rate you can get today with the rate on the bond? Does that make sense that this thing will sell at a premium? In the chat here. No. So the first answer, will this bond sell at a premium or at a discount? This thing is going to be selling at a premium. So determine the value of the coupon. The coupon, we can see it's a $600 bond and it's paying 6.5%. So times 6.5%, but it's semi-annual, so divided by 2. So we just need to multiply that out. 6.5% divided by 2 times 600. So the coupon should be $19.50. Right? That's just how you calculate the coupon. Every half a year, they get interest on the 600,000 that someone has borrowed from them. So determine the number of coupons left on the bond. Okay, now, in order to do this, what you're going to do is you're going to use something called use CoupNum, and I'll go do that. So let's go find this CoupNum calculation. I'll have to go. So I'm gonna stop sharing and I'll share my screen. If you go back to the Excel files that I sent you last week, these were all the questions, but I have a sheet here called coupon dates. So let's enlarge this. So on this tab called coupon dates, the first one here is called CoupNum. And what this is going to tell us is how many coupons there are left on this coupon. What we need to know is we need to look at the question again. So the bond matures on March 1st. That's the maturity date. And put it in here in the green box, March 1st, 2026. March 1st, comma, 2026. And the purchase price of the bond on September 1st. So that's the settlement date. Put that in here. September 1st, comma, 2020. So once you fill in these two, the frequency tells us that it's twice a year. And you probably never need to change that. And the one says we're doing actual. This is necessary because in some countries, they do these calculations and they use a 360-day year. But in Canada, we use a 365-day year. So this has to stay as number one. And so up here, it tells us 11, meaning there's 11 coupons left on this bond. You could figure this out by hand, but it's a fairly painful process. Whereas this coupon calculation does it incredibly accurately and it does it easily. So keep this file available whenever you're using bonds and only ever type in the green box. Don't type over here or you'll screw things up. But we can see that it's 11. So let's stop sharing this and go back to our whiteboard. So under determine the number of coupons left on the bond, this becomes 11. And keep your formula sheet in mind to make sure that it helps you sort of follow what's happening. So it says, find the present value of the bond. And this takes several calculations, because the first calculation we have to do is to find the present value of the bond itself. So this calculation is that the present value equals future value 1 plus I to the power of negative n. We know the interest rate is, this is using the market interest rate of 5.2%. So the face value of the bond is 600. 1 plus, and this uses the market interest rate of 5.2% divided by 2, and it's to the power of negative n, which we now know to be negative 11. So let's try and calculate that. I'm going to go 5.2% divided by 2 plus 1 y to the x 11 change sign equals, and then times 600, and I'm getting 452.41. So that's the present value of the bond, but you also have to find the present value of the coupons. And if you look on the formula
Excuse me,
sheet,
sir.
yes,
How can we solve this with the help of calculator?
let's see. We should be able to do it because we know the interest rate. We're solving for the present value. We know the future value. Let's see if we can put down what we would do here. We'd go second PY it's semi-annual, so this would have to be 2. Enter and clear. N would be, can we put negative 11 into N? Wonder if that'll work. The interest we know is 5.2 into IY. The present value, we don't know. The payment, we don't, there's 0 payment in this calculation. And the future value is 600 to future value. And we're trying to compute PV. Let's see if that works. Let's plug that into the calculator and see if that works. Second PY 2, enter, clear. 11 negative into N. Don't know whether it'll do that or not. 5.2 into IY, 0 into payment, 600 into future value,
Yes, it's give same value.
and compute PV. 7, no, I'm getting 795. What did I do different?
No, sir, I got the same answer. 452.41.
Did you use a negative 11 or just 11?
Just 11.
Just
a-
11.
11. Let's try that. And compute PV. Oh yeah, 45241. So I didn't know whether it would do what it would do with the negative 11. I'd never tried that, but it didn't work. So just 11. So yes, the answer is you could do this calculation on the BA2 plus 452.41. Let's do the second calculation. Actually, I think it'll turn out that the BA2 plus will do both these calculations for us in one calculation. Let me do this one by hand first. To get the present value of the payments, we have to do 1 minus 1 plus I to the power of negative n all over I. So this would be the payment, which is the 1950, 19.5, 1 minus 1 plus 5.2% divided by 2 to the power of negative 11 all over 5.2% divided by 2. I'm going to do the 5.2% first. 5.2% divided by 2. I'm going to store that in register 1. So now I'll go recall 1 plus 1, y to the x 11 negative equals, I'll make that negative and add it to 1 plus 1 divided by recall 1 and then times 19.5. So I'm getting 184.49, 184.49. Now, weirdly enough, over here where we did this calculation, we put in 0 for payment. Here, the purchase price of the bond is going to be these two added together. So 452.41 plus 184.49 equals. So 452.41 plus 184.49. So 636.90. Now, we could do this calculation, the 184, we could do this on the BA2 plus. We'd still be going second PY2. We'd still be going 11 into N. We're still 5.2 into IY. We still don't know the present value, but here we know the payment. It's 1.8, or no, 19.5 negative into payment. We're not worried about any future value, so 0 future value, and compute PV. Let's see if this works for us. So second PY2, enter down, 11 into N, 5.2 into interest, nothing in present value, 19.5 negative into payment, 0 future value, and compute PV. And that works. That gives us the 184.49. But I suspect that if we do both these calculations, we'll get the final answer here. So let's try it. Let's go second PY2 again, 11 into N, 5.2 into interest. We don't know the present value, but we know the payment is 19.5 plus or minus. No, I don't think we need the plus or minus here. I don't think we needed it over here either, because they're getting the payment. They're not paying it, they're getting it. So 19.5 into payment, but 600 into future value, and now compute present value. And I'm guessing that putting them both in here, we should get this 63690. Let's try it. So second PY 2, enter down, 11 into N, 5.2 into IY, 19.5 into payment, 600 into future value, compute present value, and we do indeed get 636.8990. So, Manmeet, does that help with that first one?
Yes, sir.
Okay, I'll save that and we'll look at this question. Number 1 has several parts. It gets you to do many different things. Let's go back here and find the next one, or the next part of it. So it says an alternative method for calculating the purchase price of a bond that is purchased on the coupon date a $9,000 6.7% bond with semi-annual interest coupons is bought 6 years before maturity to yield 5.4% compounded semi-annually. So will this bond sell at a premium or at a discount? So we can see that this bond was a 6.7%, but the interest rate in the market has gone down to 5.4%. So if you had a choice between an investment yielding 5.4% or an investment yielding 6.7%, you'll choose the 6.7, which means people will be willing to pay a premium for this bond. So the answer here would be premium. So the value of the coupon based on the initial interest rate. So this is the coupon calculation we did. 9,000 times 6.7%, but it's semi-annual. So let's find what the coupon would be worth. And this is the actual coupon because this is the rate that goes with the bond. So 6.7% divided by 2 times 9,000. So the coupon is $301.50. But now they want to determine the value of the coupon based on the new interest rate. So 9,000 times 5.4% divided by 2. So 5.4% divided by 2 times 9,000 is $243, and find the difference between the coupon values. So we would go 301.50 minus 243. What is that going to be? 301.50 minus 243 is $58.50. So determine the number of coupons left on the bond. Now we can't use coupon here because they didn't give us any dates, but it's 6 years. So we know it's 6 years and we know it's twice a year. So there would be 12 coupons left on this. Determine the present value of the difference in the coupon values. So what we're doing is the present value equals the 58.50 1 plus I to the power of negative 12, right? We're just finding the present value of the difference. Let's see what that equals. I is going to be 5.4%. So let's actually put that in here. So it makes, oops, that didn't work. Okay. Let's put the 5.4% in here. 5.4% divided by 2 to the power of negative 12. So 5.4% divided by 2 plus 1 y to the x12 negative equals and times 58.5. So I'm getting 42.49 there. And for some reason that doesn't make sense. What did I do wrong? Let's see, 5.4% divided by 2 plus 1 y to the x12 equals that. Times 58.5. And so but that number doesn't help me very much. So let's go back to the formula sheet because it says, gives you the alternative method, A, B, C, coupon minus market, determine the number of coupons left on the bond, and the present value of the difference. This formula isn't doing me any good. So let's use the formula they gave us on the formula sheet and see if it makes sense. Present value equals 58.50, 1 minus 1 plus I to the power of negative n over I. And that makes sense because this isn't just happening once, this is happening a whole bunch of times. So let's plug this in again. 5.4% divided by 2, and I'll store that in register 1, plus 1, and then y to the x 12 negative equals that, and plus or minus plus 1 divided by I times 58.50. And now I'm getting 592.88, which is a much better answer. So determine the purchase price of the bond. What we have to do now on the formula sheet is add this present value to the redemption price, the face value of the bond. So we're going to go 9,000 plus 592.88 and see what we get. We get 9,592.88. So this alternative method is just find the difference between the two values and then find the present value of that stream of income. So let's see what else they can do to us here. So then they give us determine the purchase price of a bond that is purchased between coupon dates. Gets a little more complicated. So, haven't given us much room to work, but a savings bond with a face value of $5,000 bearing interest at 5.2% payable semi-annually matures on August 1st, 2022. What is the purchase price of the bond on April 17th, 2020 to yield 3.2% compounded semi-annually? So will this bond sell at a premium or a discount? Let's see what happened to it. When the bond was written, it was at 5.2%. 5.2%. But the market rate has gone down to 3.2, down to 3.2%. So you're in the same situation. If you had a choice between an investment paying 3.2% or an investment paying 5.2%, you should choose the 5.2%, meaning people will be willing to pay more or pay a premium for this. So although I put this nonsense in the wrong place, the answer up here would be premium. So determine the value of the bond, of the coupon. We don't need this here. What we need to find the value of the coupon is the face value, 5,000, times the rate on the bond, 5.2%, divided by 2 because it's semi-annual. So 5.2% divided by 2 times 5,000 is 130. I hope. If it's not, let me know. Determine the number of coupons left on the bond. Okay, so now we are going to go back to our Excel file. So I'll stop sharing, no, first I'll find the Excel file. I'll stop sharing this and I'll share the Excel file. So you can, hopefully you can see this coupon dates spreadsheet that I've created that you should use. Only put numbers in these green boxes, and I shouldn't even have these ones green because you shouldn't have to ever change them. So now let's look at the question. This matures on August 1st, 2022. So that's the maturity date. August 1st, 2022. And what is the purchase price of the bond on April 17th? So on April 17th is when is the settlement date. We're going to put that in here. April 17, 2020. So once we put those two dates in, we see the number of coupons left is 5 coupons. But down here, we're calculating something called Coup Day BS. I know BS sounds like bullshit, but it's before settlement. And what we find is from the previous coupon date to the date that it was actually sold, the settlement date is 76 days. And Coup Days S stands for between the settlement dates. So there's 182 days. So when these two investors are working out the price that they'll sell this bond for, what they've found is the original owner of the bond has to get paid for 76 days out of a total of 182 days. So this guy is going to be paid for 76 out of 182. So make a note of those dates. 5 coupons and 76 out of 128. It's worth writing them down because we'll need them. 5, 76, 182. So let's get rid of that. Go back to our screen here. So determine the number of coupons left on the bond from the last coupon date. We've determined that the number of coupons is 5. That's all we need there. Determine the present value of the bond. So this is this calculation we did, the present value equals 5,000, 1 plus I, and this is at the market rate, 3.2% divided by 2 to the power of -5. So 3.2% divided by 2 equals, and I'll store that in register 1 because we'll need it. Store 1 plus 1 y to the x5 negative and times 5,000. So I'm getting 4618.51 here. And we'll make sure we like that. Okay. So then they want determine the present value of the coupons. So we're going to be solving present value equals the coupon was 130, 1 minus 1 plus I to the power of -5 over I. And we know the value of I, it's 3.2% divided by 2. So I stored it. So recall 1 plus 1, y to the x5 negative, and then make that negative plus 1 and divide that by I and multiply that by 130. And I'm getting 619.93. I've lost my chat box. I can't tell if anybody's trying to chat with me or not. No, it's okay. So what is the value of the bond on the last coupon date before the purchase? It's the sum of these two numbers. So let's add them up. 4618.51 plus 619.93. What does that add up to? 4618.51 plus 619.93. So I'm getting 523.8.44. So that would be okay if the coupon was sold on the coupon date, but annoyingly enough, it wasn't sold on the coupon date. So determine the number of days from the last coupon date to be before the purchase to the purchase date. This is what we already figured out. This is using Coup Day BS. And this equals 76. And determine the number of days between coupon dates. This was Coup Day S. And this equaled 182. So then we use the ratio of days as n to calculate the future value of the bond. So we're going to take this amount here because this is what the coupon was worth, or the bond was worth on the last coupon date. And we've got to move it forward for 76 out of 182 days. So this calculation is going to be future value equals 5238.44 1 plus I to the power of 76 over 182. So when I plug that into my calculator, I'm going to start with the I, recall 1, which is 3.2% divided by 2, plus 1, and then y to the x in bracket 76 divided by 182, end of bracket, equals, and then times 5238.44, which is giving me 5273.277, so 28. So any thoughts or concerns at that horrible calculation? Don't lose that spreadsheet that has the coup days and coupnum on it. That's going to be very handy in this chapter. So I will save that and clear that. And this horrible question is not over yet. They give us one more problem to solve here. So determine the price of a bond when payment periods are not the same as compounding periods, i.e. a general annuity. So bonds with a maturity of 55,000 and 7.5 years, bearing interest at 6.1% payable quarterly, are sold to yield 8.1% compounded semi-annually. So what can we do? Let's find out. Determine, oh, will this bond sell at a premium or at a discount? Let's see. The bond was written at 6.1. But the interest rate has gone up to 8.1. So if you had a choice between buying an investment that was paying 8.1% and an investment that was only paying 6.1%, you'll choose the 8.1%. So anybody trying to sell this investment is going to have to lower the price to make it more attractive. So this coupon or this bond will sell at a discount. So the value of the coupon, we can calculate it. 55,000, and the coupon rate is 6.1%. But notice it's compounded quarterly, so divided by 4. So 6.1% divided by 4 equals that times 55000. Now I notice that we're past 12 o'clock. So I know you have another class starting at 1. Don't hesitate to bail on this and get ready for your next class. I'll finish this calculation and I'll send this all out to you when I'm done. But you don't have to hang around just because I'm boring you with numbers because someone asked about how these questions work. But we'll go through this and we'll hopefully make sense out of them. So the coupon is going to be $838.75. So because it's a general annuity, we have to calculate P. So we need to know I equals, and this is going to be based on the market rate. So I is equal to 8.1% divided by 2. What's that going to be? 8.1% divided by 2 is 0.0405. And I'll store that in register 1 for the moment. We need to know C, which is equal to the compounding, which is 2. And the coupons being paid are quarterly, 4. So C just equals, no, not 2. C just equals 0.5. And so P equals 1 plus I to the power of C minus 1. So let's figure out what that is and store it. So recall 1 plus 1 y to the x 0.5 minus 1, and I'm getting 0.020049018 and store that in register 3 or whatever register you want. I'll always store it in register 3. Now, you don't want to round this number off, so I would make sure you can store it. So that's our value of P. Determine the number of coupons left on the bond. They haven't given us any dates, but they have told us that it's 7.5 years and coupons are quarterly. So let's figure that out. 7.5 times 4 is 30 coupons. Determine the present value of the bond. So present value equals 55,000, 1 plus, now this is P, to the value of -30. So recall 1. Uh-oh, I didn't store it. What an idiot. Oh no, recall 3. Recall 3. And I still didn't store it. So I have to do that again. Recall 1 plus 1. Y to the x 0.5 minus 1. I said store that in register 3, but I didn't store it. Now I've done it. Plus 1. Y to the x 30, change sign, times 55000. So I'm getting 30,320.16. For some reason Moodle wants 0.15, but 1/6 will still work. So determine the present value of the coupons. Present value equals, and the coupon we determined was 838.75, 1 minus 1 plus P to the power of -30 over P. Let's see what we get there. Recall 3 plus 1, y to the x 30 negative equals, make that negative, plus 1 divided by recall 3 equals, and times 838.75 equals, and I'm getting 18772.37. And so the purchase price of the bond would be these two added together. So 30320.16 plus 18772.37 equals 30320.16 plus 18772.37. I'm getting 49092.53. So, yeah, I hadn't intended to go through those questions, but I'm sure many of you are glad I did go through them, and you can see them because it'll help when you try to go through them. So I will say goodbye for today.
Thank you, sir, so much.
And I'll send those pictures to you. I'll also remember to send the update of the Excel file to you. And when this uploads, it probably won't upload till tomorrow. You can rewatch this whole exciting video on YouTube. Okay, take care. Have a good day.
Thank you, sir.
Bye.
Bye now. Hope my cup doesn't say anything rude on the back. But